So welcome to part 3 of this series. In part 2 we discussed the beginnings of inverse ARP and how it solves that problem of mapping a distant end IP address that we want to reach to a local DELC that it can be used to reach that distant end IP address. So to kind of go more in depth about that, we're going to discuss inverse ARP on the different configurations and what that means when you disable it on one side and what happens and whatnot. And then we're going to disable it completely and kind of come to the second solution of how you complete the mapping between IP and DELC, distant end IP and local DELC. So keep in mind again that inverse ARP will only announce on an active DELC, and it's the frame relay switch with those with the keep alives coming from the routers that determines what DELCs are active, right? So if there's no communication happening between R4, the frame relay switch, and R2, there's no keep alives and the interface is down or just not configured right, DELC 102 will not actually become active because its outgoing side, its completed virtual circuit side, is not up, active, and complete. So keep in mind again that an active DELC is only active when both sides are up, operational, and configured correctly, with the keep alives happening every 10 seconds successfully. So let's go into inverse ARP a little bit more and what it means to disable it on an interface. And what we'll do is we'll bring R3 into the mix, and the DELC virtual circuit is 103 from R1 to 301 to R3, 302 to 203, that's complete virtual circuit, and then 102 to 201 bidirectional circuits. So we'll bring R3 into the mix, and we'll add an IP address 10.0.0.3, right? Encapsulation frame relay. Not going to state the LMI type, so it'll try to auto detect what's configured on the frame relay switch. Let's see if it's up. It's not up right now. So what I'm going to do is I'm going to go into R1 and disable inverse ARP. So when you disable inverse ARP, what you're doing is that R1, once it receives a DELC that's active, once it detects that a DELC is active from the frame relay switch, when you disable frame relay inverse ARP, it won't actively send an announcement. It won't try to query the other side, but it will respond to any queries from a distant end. So if you want to disable inverse ARP completely on both sides of the circuit, you have to disable it on both sides of the circuit, inverse ARP, because even though you disable it, it will still respond to inverse ARP requests. And that's what we'll see here in a moment. So let's go ahead and disable it on R3. And it's enabled on R2. So R2, since frame relay inverse ARP is enabled on R2, once it detects that a DELC is active, which is 201 and 203, since R3 is coming online, 302 will come up because there's keep alives that are happening between the frame relay switch and the router. So 203 will now become active. R2 will then send an inverse ARP announcement request to whoever's at the other end of that virtual circuit requesting their IP address. So that will happen between R2 and R3 and R2 to R1, but you'll notice that we disabled inverse ARP on R1 and R3. So either one of these routers will not announce or will not query an active DELC what the distant end IP address is at the other end of that virtual circuit. So what we'll see is we'll see our frame map complete with R2's IP address, which is 10.0.0.2, and it's reachable via local DELC 302, which is connected to 203 on this interface. You notice we don't have R1's inverse ARP information because we disabled it. R1's not going to try to query the distant end. And if we go to R1, we don't see R3's IP address, distant end IP address to a local DELSI because R3 did not try to query R1. But we do see R2's distant end IP address because R2 did send in a request out both of these active DELSIs, and even though you disable inverse ARP, it will respond to any inverse ARP request. So just keep that in mind. If you want to disable it completely, you have to disable it on all routers to ensure that inverse ARP is completely not available to any of the routers. So let's go back to our problem, right? We have R1 and R3. Now, we know that if we want to communicate to R3, we can just send frames with a DELSI identifier of 103, and the frame relay switch has a connection between 103 and 301 on this interface to R3. We know that, but the router doesn't know that because inverse ARP is not operating. It doesn't know the distant end IP address. So if we go into R1 and we try to ping 10.0.0.3, we're not going to get any response because R1's going into its frame relay map and saying, you know, do I have a DELSI identifier that I can put on my frame relay frames so that it can reach the other side of that virtual circuit, which is R3. And the problem is that we don't have that. So how can you solve that problem? Well, you can statically assign the IP address to a DELSI. And if we go into serial 10, you can use what's called the frame relay map command, which is statically inputting IP address to a DELSI, right? Frame relay map. And the next is going to be the what type of protocol, and we know we're going to use IP. And the IP address at the distant end of that DELSI is 10.0.0.3. And the DELSI, local DELSI to reach that other end is 103 because 103 goes to 301. Let's just verify in our frame relay switch. We are on serial 00 from router 1. We want to reach serial 12 to router 3. So from serial 10 to 12, here it is, serial 10 to 12, that's our communication. We need to send from router 1 DELSI identifier 103, and on the other side to serial 12, which R3 is connected to, it'll be relabeled 301, right? Now if we go down to serial 12, coming back the other way, it just so happens that the DELSI identifier is the same. Serial 12, DELSI 301, if we send information, if we send frames and data with DELSI identifier 301, it'll get translated to 103 and eventually reach R1. So we need to create a map on R1 that says, if I want to reach distant end IP address 10.0.0.3, we need to use DELSI identifier 103 on that interface because it goes to R3. 103, right? And we'll just go ahead and hit enter. Now coming back the other way, it just so happens that on the interface to R3, if we want to reach R1, we need to send with the DELSI identifier 301. So let's go into R3, serial 10, map IP 10.0.0.1, right? And we need to send it out DELSI 301 because DELSI 301 will eventually reach R1 on DELSI 103. Hit enter. Now if we do our do show frame map, alright, we see that here. We're on R3. If you want to reach 10.0.0.1, just label your frame with DELSI identifier 301 and the frame relay switch will take care of the rest since it has that mapping. Alright, so with that, I'm on R3. I should be able to ping I should be able to ping R1. And we can. We can ping R1 fine, just perfectly. So that's inverse ARP. Disabling it, just keep in mind that you need to disable it on both sides, right? Or else it'll still continue to operate. It'll still continue to respond to inverse ARP requests. So we learned that the frame relay map command can provide that static mapping between distant IP address and local DELC, right? So it kind of brings into the next video of what that means to particular interfaces, and we'll get into interface types. When you have a bunch of DELCs going between each one of the routers, you can actually separate them out, create different networks. We'll go into that in the part 4. But this completes the inverse ARP. It's kind of like an inverse ARP type part 2, and solving that problem of creating the mapping. So I hope you enjoyed.